Hello students, welcome to the world of chemistry. Today we are going to discuss about D block elements. This video is very helpful for BSc second year student. Now you can see in this periodic table the yellow part showing all D block element. D block element are also called transition element because they are situated between S and P block element. These are the S block element and these are the P block element. Okay, so they are situated between S and P block element. They are also called transition element. So why they are called transition element? Because their d orbital is incompletely filled or partially filled. So we can say that all d block element are not transition element. The element or those elements which have incompletely filled d orbital, they are called transition element. Now let's see which elements are present in this d block element. So from scandium to zinc, this is called 3D series. From yttrium to cadmium, this is called 4D series. Lanthanum and actinium, we will study those elements under F block element. So from hafnium to mercury, this is 5D series, and from rutherfordium to copernicium, this is called 6D series. They all are D block element. Now let's see the properties of this element. So the D block elements, they are all metals. Okay, so you can see that they are all metals. Then many transition elements show different type of colors. Then they show paramagnetic properties. We know that all P block element, they are non-metal, or they also form colorless compound, but all D block element forms different type of colorful compound. Then the property of transition metal depend upon the electronic configuration of metal ion. Also they show the properties of metals. You know the properties, what are the properties of metals? Let me know in comment section. Then they show variable oxidation state. They form alloy with different metals. Also they show catalytic properties. Okay, so these are some important properties of these metals. Now let's see the electronic configuration of metal. You can see that the general electronic configuration for D block element is Ns0 to 2, N-1 and Dx, where N is equal to 4. Now for 3D series, N is equal to 4. For 5D series, N is equal to 5. Okay, this value changes as we move down the group. It is up to 7. And we know that the capacity of D block element, it is up to 10 electron. So from 1 to 10. So the value of this X is from 1 to 10. Okay, now you can see that there is a N-1. Why this is N-1? Let's see the example first. Okay, so let's take example of scandium. Scandium, their electronic configuration is 4s2 3d1. Okay, now here the 3d orbital is inner orbital and this 4s orbital is outer orbital. But according to above principle, electron enter into energetically lower orbital and then it enter into energetically higher orbital. Okay, so we know that rule. So firstly in scandium, electron enter into this this 4s orbital. Okay, then it enter into 4d orbital. Okay, but 4d orbital is inner orbital while 4s orbital is outer orbital. Okay, means our last electron entering into penultimate shell. So what is penultimate shell? The shell between the shell before last shell or before valence shell is called as penultimate shell. So if 4s is our valence shell because it is outer shell, then 3d shell is our penultimate shell. Okay, so that's why the electronic configuration is for scandium or for general electronic configuration, this is given n minus 1. Okay, so for all transition element, the last electron or the valence electron enter into penultimate shell. Okay, so the electronic configuration is n minus 1. Okay. Now let's move towards the electronic configuration of first transition series, that is 3D series. So first transition series contain compounds scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Their atomic number is started from 21 up to 30. They are total 10 element in first transition series. Now you can see that the electronic configuration of scandium, it is 3d14s2. So 4s2 is almost common for all element. Now you can see there is irregularity between electronic configuration in case of chromium and copper. Okay, you will think that the electronic configuration of copper may be 4d, 3d4, 4s2, or in case of copper it is 3d9, 4s2, but you can see that there is a irregularity in configuration of chromium and copper. It is called anomalous configuration. So why this anomalous configuration occur? This is because you can see that the electronic configuration of, in case of chromium, 3d5 4s1 is half filled electronic configuration, and in case of copper it is 3d10 4s1, it is full filled configuration. Whenever there is a half filled or full filled electronic configuration, the stability of that element is increases as compared to other element. That's why this anomalous configuration occur in case of chromium and copper. Now let's see some periodic properties of transition element. So trained in properties of transition element, the most common are atomic size, electronegativity, ionization energy, their metallic property. So let's see one by one. In case of atomic size, we know that as we move in periodic table from left to right, the atomic size decreases from left to right. Okay, and up to down atomic size increases. So atomic size is inversely proportional to ionization energy. Okay, so from left to right in periodic table, ionization energy increases. Okay, because the size of atom is becoming smaller and smaller, it is hard to remove outermost electron. What is ionization energy? It is the energy required to remove outermost electron or valence electron from gaseous atom. Okay, so the energy, whatever energy we need to remove outermost electron from atom, if the atom size is smaller, it is the their attraction from nucleus to outermost orbital is more due to smaller size. That's why we need more energy to remove that electron. That's why as size increases, as size decreases from left to right in periodic table, the ionization energy automatically increases. But there is in case of transition element or transition metal, there is some irregularities between atomic size and ionization energy. Also in case of electronegativity. What is electronegativity? It is the tendency to attract electron itself. Okay, it is the tendency of atom to attract electron itself, because these all transition elements are metal, they are metallic in nature, that's why they have low electronegativity. So, but in periodic table from left to right, electronegativity increases. Okay, remember that point. You can see in this picture the atomic size from scandium to zinc, atomic size gradually decreases, but you can see that from chromium to copper, atomic size, there is no much difference between atomic size. Okay, and in case of zinc, the atomic size is slightly more. Also in case of electronegativity, the electronegativity, you can see that the electronegativity increases from scandium to zinc, but in case of zinc, the electronegativity is slightly lower as compared to copper. Also, first ionization energy for 3D series, it is from scandium to copper. The ionization energy is gradually increases, but in case of zinc, the ionization energy, first ionization energy is much higher as compared to other element. Okay, so in case of ionization energy, we know that the zinc is here, the zinc have completely filled outer orbital, or their electronic configuration is completely filled. That's why it is hard, or it is not easy to remove electron from zinc. Now in case of atomic radius, you can see that from scandium to zinc, the atomic radius is gradually decreasing, but in case of chromium to copper, there is no much difference between atomic radius. This is because we can say that all the electron are entering into same d orbital. Okay, so the shielding of d orbital is less as compared to other orbitals. Okay, so due to less shielding effect, there is no much difference between atomic size. For shielding effect, I have already shared video on shielding effect, so you can watch that video. Now in case of zinc, you can see that in case of zinc, the atomic size is slightly or more, atomic size is more as compared to other elements. This is why, this is because there is a inter-electronic repulsion. Due to that inter-electronic repulsion, the size of zinc is slightly larger as compared to copper. Okay. Now you can see this, the atomic radius, electronegativity and first ionization energy of 3D, 4D and 5D series in this graph. Firstly, the atomic size or atomic radius, in case of it is there is decrease and then there is increase. Also in case of electronegativity, there is no fluctuation. You can see that there is a fluctuation in electronegativity also in this chart. Also in first ionization energy, there is a different, or there is also fluctuation. There is no gradual decrease or there is no gradual increase in ionization energy. Now let's see the oxidation state of first transition series, that is 3D series. Okay, now you can see this in slide. From scandium to zinc, there is a variable oxidation state shown by metals. Okay, scandium show +2 to +3 oxidation state. Also zinc show only +2 oxidation state, and in case of manganese, the highest oxidation state shown by manganese, that is +7. You can see that here the highest oxidation state shown by manganese, that is +7. Okay, now why this there is a variable oxidation state in case of transition element? Because there are up to 1 to 10 electron present in their orbital. That's why it is they easily loses electron. So what is oxidation state? Oxidation state is charge on that particular element. Okay, so if any element loses its electron, then their oxidation state is positive, and if it accept electron, then their oxidation state is negative. Okay, so in case of metal, always remember that in case of metal the oxidation state is always positive, and transition metal show variable oxidation state from +1 to +7. Okay, let's take example. In case of scandium 2+. Okay, in case of scandium 2+, which electron we remove firstly? The question is, we have to remove electron from which orbital? Okay, now let's see the electronic configuration of neutral scandium atom is 4s2 3d1. Okay, we know that the electronic configuration for neutral scandium atom is 4s2 3d1. Now 4s is outer orbital and 3d orbital is inner orbital. Okay, so we have to remove electron from 4s orbital. Okay, so we will remove electron from s orbital. So what is the electronic configuration for this scandium 2 positive? It is 4s0 3d1. So you have to remember that whenever you need to remove electron from any transition element, firstly remove electron from s orbital and then remove from d orbital. Okay, so that's it for this video. In next video I will share remaining part, that is coloration, magnetic property, catalytic property. In next video I hope you understand the periodic trend in transition metal. Let's see other important point in next video. Thank you.